We have AC single phase motor. We have 4 wires coming out and we don't know which one is for what purpose. So today I'm going to show you how you can find out. We have gray, white, yellow and purple color wire. What we need to do now is measure the impedance between each wire, and one wire will have a greater impedance with other 3 wires, and that will be our common wire. So it's not complicated, just follow the steps and you will make it. So first we need a multimeter set on ohms or impedance, and to be easier I clip 2 alligators clips on the test probes, so I don't need to hold, I just clip it on and that's it. So first probe will be on the first wire like this, and the second will be on white. So now I have gray and white. 566 ohms. Gray and yellow 701. Gray and purple 788. So this wire with all 3 has around 600 ohms. Let's transfer probe on second wire. Oh, you see, it's 222 ohms between white and purple, and between white and yellow 134, and between purple and yellow 87. So you see, between each of these 3 wires the impedance is less than 200, and if I transfer between the gray and any other wire it will be above 500. So this is what I'm talking about. This one is neutral and this is group of speed. Let's check again. 700, 701, 566, 788. Between only these 3, 222, 87, 134. You see, it wasn't hard. So this one is neutral or common wire to the motor, and this is speed windings 1, 2 and 3. And how we will find out which one is what speed is again easy. So we will connect, now that we know this one is neutral or common, we will connect one probe to here, and we need to write down so we don't forget. Between gray plus white 566. Between gray plus yellow, so 701. Between gray and purple 788. White wire, it has a lowest number is speed number 3 or fast. Yellow wire is medium speed or number 2, and purple wire is number 1 and low. Okay, see, it wasn't that hard at all. Now I will hook up the test leads and we will see it was correct or no. So I will hook up the neutral wire on gray or common and phase on one of the winding, let's say white. And now the motor speed will be the fastest. Okay, take it out. Let's try gray and yellow, should be medium. And let's see, purple and gray should be the lowest. So we was correct. Now we know each wire which speed it is and the purpose of the wire. So we have group of speed and common. Let's mark it. So lowest speed will have 1 dot, the medium will have 2 dots, and the 3 speed will have 3 dots. And this one will be common. Here on the motor we have capacitor. One of this wire is connected to the common wire, and we will test which one, and one is going from the capacitor to the starter coil. So let's disconnect this one. The multimeter is ready. We need to again place it. Now it will not be on impedance. We need to select the continuity, which will have this number, this sign as a speaker. So when we connect two probes, it will make a sound. Okay, so we said that we need to find out which wire is coming to the common wire. So I hook up one end to the gray, and now, okay, so it's the third wire. So neutral wire will come from the neutral lead that we connect, and it will go into the capacitor, and from capacitor it will go to the starting coil. Something like this. So gray wire will come here and it will split on two. One will go to the starter coil and the one will go to the capacitor, and also the red wire will go to the rest of the windings, like this. In the last video we learned how to identify each wire, and in this video I will show you how to change direction. So I will hook up the neutral wire to the common and phase to any of the speed, and if we observe the rotation, we can see it's rotating clockwise. How to change direction? Well, we said also that neutral wire that was connected to here is leading to the capacitor. So it's the same wire that is splitting on starter coil and capacitor. And what we need to do now is, this one stays in place. We take the other part of capacitor, exit to the motor, and we unhook this winding that goes to the motor, and we connect one of speed wires to the capacitor, and phase is now going here to the motor, and the neutral stays the same, so on the common. And now we can see it's rotating anti-clockwise. So to resume, so before it was connected, the phase was going to the one of the speed, the neutral was splitting with white wire to the capacitor and the start windings, and the exit of the capacitor was going to the motor and it was turning clockwise. And now we have other scenario that we pushing the phase through the, that was previously exit from the capacitor, now the phase is entering to the motor, and the exit of the capacitor is hooked up to the one of the phases, and neutral stays the same. And we saw that now the rotation is clockwise, anti-clockwise. And if we put everything back to normal, place a neutral, place a phase, now we'll see it will go clockwise. Okay, I hope we learned something today. Thank you for watching and goodbye.